Okay, hi. We are from Interactions Lab in UNIST, and I'm very happy to share our idea, Beach. There is a tapping gestures for smartwatches. Okay, as you know, the wearable technologies are entering the mainstream, and especially smartwatches are one of the main product categories in this space. But there is a problem with small screens. Because of each screen size, the objects have become small, so touching those, like this figure, touching the small object is very hard. Also, it blocks feedback, so when you are using this kind of keyboard, it is very hard to know what you're doing. So this is famous bad finger problem, and many people are trying to solve this kind of problems. So these two examples solve the problems by adding additional physical controller. So as you know, the Apple Watch used separate physical controllers, which is a crown. So this was for the zooming or scrolling. And similarly, at the SIGCHI, they regard watch's body as some kind of real joystick. So it can be twisted or tilted or clicked. So these additional physical controllers enables you to do something, and also to see something at the same time. But while these techniques tackle the screen size problem directly, but they also come at a cost. It is difficult to integrate with the currently dominant touchscreen paradigm. So we thought there is a value in exploring novel interaction techniques that operate with the existing touchscreen. So we focused on the tapping gestures. So left paper from Kai 13 shows how a series of separate taps that starts on a bezel can call up the menus and issue the commands quickly. Also, right paper at SIGCHI shows how a spatially separate and rapidly sequential touches can be efficiently used for menu system or some gestural keyboard input. So we inspired by these prior studies, and also we wanted to leverage the benefits of the tapping style of interactions on smartwatches. So we introduced the Beach, two-finger rapid tapping gestures. So let me show you the video first. Okay, those are the three different spatial sequential touches. Let me show you the slow motion again. You can see that first tap is simultaneous, and second two taps are sequential. Okay, these can be distinguished by sequence and position and event. For sequence, there is a simultaneous touch and also sequential touch. And also for position, there is a left-right gesture and right-left gesture. Also for event, there is a touch event or release event. So with these, we made 18 beating gestures. And before seeing those, I will going to explain the characteristics of each gestures. So at first, it operates with the existing touch screen. So we try to make a better use of current sensing hardware. Also, it enables rapid execution of commands by providing more input space rather than just using many taps and swipes. And also, there was no interference with existing single-finger UI because we made beating system only valid when two fingers are on the screen. And finally, rapid tapping gestures by 2 points are very unlikely to be occurred by accident. So it should be in less chance of inadvertent input than one finger input. Okay, those are the possible Beach movements. So for touch, there are dual and left-right and right-left touch. And in terms of release, there are the 6 release movements, including those kind of hold gestures also. So in total, there are 18 gestures, 3 by 6. And we wanted to explore the feasibility of these beach gestures in smartwatch. So to do that, we conducted 2 studies. In user performance study, we wanted to capture how people can actually perform these beating gestures. So in beach gesture design, beach interaction design, interface design and user study, we built 5 interface prototypes using beach techniques. Then we gather the user's opinion and reactions on this interface. Okay, first, in user performance study, to do this study, we made a custom watch type hardware look like this. There are two reasons we made this prototype. One is that we wanted to get a precise as possible touching sensing to distinguish the simultaneous and the sequential tapping. Second reason was that most of smartwatches doesn't support multi-touch at the moment. So we made this kind of PCB cover version of this prototype. Inside of this prototype, there was a capacitive touch sensor that refers the touches every 4 milliseconds. Also, it has a typical smartwatch size screen. Okay, with this setup, we try to understand how people can actually perform these beating gestures. So there were 18 participants per experiment design. There were 3 counterbalanced blocks, and each involved with only one touch gesture. So the purpose of these 3 blocks was to provide users with a chance to train beat gestures, because we were not interested in the novice performance. And in the end, ultimately, we wanted to examine the performance after some experience. So in the final condition, we present full gesture set. Okay, and this is the simple example for experiment design. And basically, just each participant tapping a lot. Okay, then we regard 1/3 of each condition as a practice. So in total, we retained almost 4,000 trials for analysis. Okay, let's show this graph. This is the graph about mean time plotted by each beating gestures. And as you can see, the mean time will vary from 0 milliseconds to 600 milliseconds. And it might relate to the different complexity for each gesture. And average time for a solo condition was 355 milliseconds, which is very fast, especially in this kind of smartwatch form factor. Even the average time for final condition was 313 milliseconds. This was kind of interesting because final condition was more difficult than solo condition. So this suggests that the participants learned beating gestures very quickly. Okay, more interesting is in the beating time histogram for each touch and release gesture. At first, we removed outliers. Then you can see that this blue graph, there is blue graph, and this blue graph is about dual gestures, and it was much faster than the sequential gestures. For general conclusion, most of simultaneous gestures occur in less than 30 milliseconds, and likewise, most of the sequential gestures occur in less than 400 milliseconds. So those values can be used as a good threshold for these beating gestures. Also, we also recorded errors. So this graph is about mean errors per participant plotted by a release condition. So the blue bar is about extra error, which means there was an extra input after correct gesture. And this occurs at front of 3 release condition. And this might relate to the experimental artifacts that people just wanted to end the task quickly, so they may just release their finger earlier than the end of the task. Likewise, the red bar is about the incorrect error. This is related to the wrong sequence of taps. We concern this more than the extra error because incorrect error indicates how each gestures were hard to perform. So in here, we can see that error and other release was difficult to perform. Anyway, the overall error was just about 5.5%. So we think that this is very low value for experimental setting. Okay. Then we explored how these beating gestures can be integrated with the interface. So we created 5 interfaces, and those implements was on a typical Android phone. And it refers touch events every 10 milliseconds, and it was sufficient for beating gestures. And to test it in smartwatch environment, we restricted its screen each screen to typical watch size, typical smartwatch size. Then I will introduce each 5 interfaces. Okay, first one is shortcut menu. And by dual tapping, we can call up the shortcut menu. Then by using LR and dual and RL release, we can trigger left or center or right menu items. Okay, and this is the button menu example with a map application. So with the right left tap and left release, we can call up the button menus in the left side. Okay, and then by tapping with the left finger, which is the raised finger, then we can select each buttons. So let's check in the video. Yep, like this. So you can see that it allows rapid access to commonly used commands. Okay, and this is the stroke example with a message application. So with the right left tab and right release, we can display the file menu like this, and then we can issue each command by stroking with the on-screen finger. Let me show you the video. Yep. So this shows how beating gestures can be combined with a single finger stroke gestures. This is the alarm clock example. So we can toggle clock and alarm. We can toggle clock and alarm with a dual tap and release. Likewise, we can toggle alarm and on and off with a single tap and release. Also in alarm mode, right finger tap and left release and right stroke will always used to adjust the hour. Likewise, to adjusting the minute, it was the opposite gesture with the adjusting hour. So you can check in the video. Yeah, so it was quite rapid. And final example is a music player. With a single tap and release, we can do play and push like other UIs. Also, by dual tap and stroke, we can control volume. To go next song, left right tap and right release, and then left right is needed, and then just tapping with the right finger will execute the next song command for each tapping. And previous song is just opposite, so you can check it also in the video. Dual tap and drag for volume control. Yeah, we can also do the next song and previous song commands. So with these UIs, we wanted to gather a subjective commands and opinions regarding the interaction. So we exposed those prototypes to 10 users, and it was an informal show, try, and tell study. So it was not formally evaluated. Okay, there were 3 themes, and I'm going to look through these commands. First theme is about speed and access. So usually there are ratio steps to access apps, but not here. So it was very fast, and it was quick to use for setting times, and functions available right away. Like this, many commands was about the rapid issuing commands. Second theme is about UI integration. So some people liked finger still on screen gestures, like from the stroke and alarm clock example. And some says that beating gestures and stroke was easier than touching some specific icon. Also, some says that dual tap to set the volume was interesting and easy to use. So here we can see that it was okay to integrate beating gestures to UI, and even it was well matched with the current single finger UI. Okay, third theme is about running, and it was unfamiliar and it would need to be run at first, but it was tempered after use. So it became accustomed and felt okay, and also after a few moments, easy and comfortable. So we can also found that each unfamiliar can be tempered with practice. Also, to reduce this confusion, we can just use limited input vocabulary with a few repeating gestures. So this is all. And if you wanted to see the demo, please come to us to see this kind of demos. And thank you for listening.
We have time for some questions.
This is Janie from KAIS. Thanks for the great talk. I just had a question about, you little mentioned in the previous slide about the users having to learn before the trials and using the gestures of AT movements. Okay. I was wondering how long did it actually take for them to actually be familiar with the system?
You asked about how they trained about these fitting gestures before do the final condition.
I mean, like, how long did it take for them to become familiar with the gestures?
Actually, there was a post. Okay, let me show you the one. Actually, there was these 4 sets of 4 blocks, and for these 4 blocks, it takes about 30 minutes or 30 minutes to 40 minutes.
So about 40 minutes. Okay,
yeah.
Thank you.
Yep.
Hi, I'm Paul from Postec, and unlike your experimental setting in the realistic situation, it might be like opposite like direction to tap, like right to left and left to right. So do you have you considered that situation to distinguish these 2 inputs?
I'm sorry. Can you
like
say
when I tap like this, it can be like left to right can be in the opposite way.
When you just touch like this and this right.
Like if I don't need to see the result or like see the watch at that time, and then I'm just controlling, for example, like music, I can just touch like this, right? Then have you considered to distinguish that, like, if there is right to left or right to left or left to right? Yeah.
Okay. We didn't think about that kind of use with this gesture and this gesture, but maybe that's also interesting. But anyway, we didn't think about that kind of gesture.
Yeah, thank you.
Hello, I'm Yukang from Tsinghua University, and I have a question that compared to other gestures like swipe or tilt or zoom, there have some meanings related to the functionalities. So do you have something to guide to map the functionalities to your gestures?
You mean just do we map with the kind of zooming or something with this kind of face gesture?
So
mapping with a face gesture.
How can we map the functionalities to the gestures and make them very natural and easy to use, or to have some guidance?
Okay, actually we just wanted to provide more input space, and with the input space we can make the kind of, as you saw, the button menu or the kind of menu systems, but we didn't map to some beating gesture to zoom in and some beating gestures to some swipe. We didn't do that kind of things in this paper.
Yes, thank you.
Okay.
Let's thank our speaker.